Okay, I'm sorry about that. That glare was really getting to me and I couldn't concentrate. Okay, so here are all of the numbers and their corresponding names. So we have meth, eth, prop, bute, pent, hex, hept, oct, non, and dec. You don't have to have those memorized, but you should keep this handy. This would be something great to print out, maybe cut out the little slide and, I don't know, tape it to your computer monitor, I'm not sure. Whatever you feel like doing. Okay, so going back to our example, identify the prefix that goes with the number. We identified our longest carbon chain as having 7 carbons. 7 is hept. So we know we should have hept something. Okay. Now, step 3 is to, oh, I'm sorry. There's another step to step 2. Because we're talking about alkanes, we're going to add the prefix ane, the suffix ane, A-N-E. The great thing about nomenclature for all of these compounds is that it's pretty obvious what type of compound you have. See this? Alkanes. All of our alkane compounds are going to end in A-N-E. That's easy. Okay, so we had hept ane. Now, step 3 then is to identify all substituents. Remember, substituents are anything that's not one of those implied H's. Identify all substituents and name them. Then we're going to alphabetize. All in number 3. And then we're going to add those as prefixes. Remember, that's where that goes. Add as prefixes to the result from step 2. Okay, now, in that example that I showed you, that was just one carbon chain. It didn't have any substituents. So the name of that compound is just heptane. That's all there is to it. Let's do some more examples. Name this compound. This is a tricky one. Here you don't have a horizontal or a linear longest carbon chain. That's your longest carbon chain. Okay, so step 2 says to identify the number associated with that number, or the name associated with that number. That's dec. And then to add the A and E. So we have decane. And now going back to step 3, identify all the substituent groups. There's only one substituent group that isn't that implied H. That's this thing right here. Now what we're going to do is number this. 1, 2, 3. You don't number the join because you've already numbered it as part of your carbon chain. Okay? So you have a substituent group of 3 carbons. Now the way we're going to do that is to look at this chart. When you are going to use these as for substituents, you're going to add YL to identify it as a substituent. So in other words, we can't just say methane decane. That doesn't make any sense. We have to put that YL at the end of our base parent name to make sure that we're aware that that's the suffix and not the carbon chain. Okay, so here we have this 3 carbon chain. 3, the word for 3 is prop. So when we use it as a substituent, we call it propyl. Now, we can put that here. So we have propyldecane, one word. And now the only thing that we have to do yet is to identify where that propyl group is sitting exactly in our molecule. So here's where numbering comes into effect. You're going to identify that it's on carbon 4 by putting a 4, then a dash, and then the name. So the name of this particular compound is 4-propyldecane. Now, a couple of things that I will take off points for. Firstly, things to watch out for. In other words, things I'll take off points for. The first one is that all numbers and words are separated by a dash. So if you have a number and then a word, they're always separated by a dash. Same thing if you have a word, then a number. So if you were to have 3-methyl 2-butyl, all of those things are separated by dashes. You can't put them together, and we don't just leave a space. If there's no dash there, you're going to get, it's not right. You have to use the convention. And that is to put the dash there. The second thing is that all numbers, if you have 2 numbers in a row, all numbers are separated by commas. I have no idea why it does this, and it's so irritating to me. Okay, so if you had something like 3,3 dimethyl, here you have 2 numbers. They have to be separated by commas. Here you have a number and a word separated by a dash. Don't get that mixed up. We do not write this. That's a dash there. That's not word, or excuse me, that's not number, word. That's number, number. That gets a comma. Okay, so what does all this nonsense mean there that I just went on a tirade for you about? This comes into play when we have a more complex molecule. Okay, find your longest carbon chain. In this case, it's the one that's going horizontally. Number it. Now, the thing with numbering is that you're going to want to start closest to your first substituent. So here, this is not as close as over here. So we have 8 carbons. Always, always, always start with that parent. That's the easiest thing to do. We have octane. Now we have to identify, though, and name those substituent groups. Well, here we have one and one. Okay, so there's 3 of the same thing. They each have 1 carbon. That substituent is methyl. So we have methyl. Now, when you have 3 of the same thing, you have to identify that as 3. You have to identify where each of the methyls are. So we're going to write 3, 4, 5, and then you're going to write the line to separate word and number, and then you identify how many of them there are. 3, 4, 5 trimethyl. So it's a little bit redundant in the fact that you have to write those 3 numbers in front, 3, 4, 5 trimethyl. And then you'll write the octane back at the end. 3,4,5 trimethyl octane. Okay, let's do another example. This looks like a fun one. Okay, let's start out by numbering. And remember, we want to number at the end that's closest to our first substituent. Okay, so we have 6. What is your parent name? Hexane. Okay, now let's go through and name all of our substituents. Well, let's start from left to right. Here we have 2,3 dimethyl. And then we've got something on that 4. We have 4 ethyl. And then that's all. Okay, so here are my substituents. But remember, we have to alphabetize them. So we go by the parent group, well, yes, we go by the parent thing. We don't, prefixes don't count. In alphabetizing. Okay, so which comes first, the E or the M? The E. Okay, so we have to rearrange this a little bit. So our correct whole name of this compound is 4-ethyl, 2,3-dimethyl, hexane. 4-ethyl, 2,3-dimethyl hexane. That's a mouthful. That's pretty fun, right? Okay. Send this to me with the correct name by noon on Friday, and I'll give you 1 extra credit point on your homework. Give you a hint. The longest carbon chain is not the linear one. That looks fun. Okay, so let's talk about naming for when we have cyclic alkanes. What do we do if there's a ring? So step 1 is to count carbons in the ring, add cyclo at the beginning. Oh. At the beginning, and ane at the end. So basically the same type of rules that we were doing before with regular alkenes, except that we just add cyclo at the beginning. So instead of hexane, it would be cyclohexane. Step 2 is, to number the ring so that the first group, the first substituent group, alphabetically. Oh golly, I know I can't even spell. It's getting to me. Okay. Okay, after I'm done writing this, I will recap this for you. Number the ring so that the first substituent group that comes alphabetically is the first number in the ring. Okay, so let's, and then 3 through 5 are the same as for alkanes. Okay, let's do an example. Okay, name this compound. Okay, firstly we want to try to figure out where we're going to number. Now, you can number either clockwise or counterclockwise, but there's a right way and a wrong way. So our goal when we number is to try to make everything have the smallest number possible. So if you're ever getting something where you have 6-methyl-cyclohexane, that's wrong, because that number should be as small as possible. And since you can start numbering anywhere, you should try to make that number 1. Okay. So firstly, let's look here. We have a methyl group and an ethyl group. Which comes first alphabetically? The ethyl. So let's start numbering here. Now, here's where it gets a little bit tricky. You have to decide if you're going to go clockwise or counterclockwise. Well, you're going to want to try to make your next substituent group the smallest number possible. So in this case, we're going to go counterclockwise. Okay. Take a breath. The first step says that we then have to add the cyclo and the ane to our prefix, or to our parent name. So here we have cyclopentane. And now we just have to follow the rules as before. We have an ethyl, we have a methyl. 1 ethyl, 2 methyl. Oh, I ended right perfectly. 1 ethyl, 2 methyl cyclopentane. That's a mouthful. Let's do some more. Ooh, this looks like a fun one. Okay, so we have 3 methyl groups. And we have a propyl group. That's this thing here with the 3 carbons. Which comes first, M or P? M. All right. Now, there are a couple of ways of numbering, but there's only one right way. We want to try to get everything to have the smallest number possible. 1, 2, 3, and these are all unimportant as far as numbering goes. Now, the reason this is the right way is because if I were to start here with my number 1, that means I would have a 1, a 2, and a 3, and 2 3s. 1, 2, 3, 3. I can make those numbers smaller by saying 1, 1, 2, 3. So that's why the counterclockwise way is the right way. How fussy am I going to be about this? Not all that fussy. All right, so here we have a cyclohexane, and we have got 3 methyls, so that is 1, 1, 3 trimethyl, 2 propyl cyclohexane. In organic compounds, all of the letters are lowercase, nothing is uppercase. And these words, this is all one word. 1,1,3 trimethyl 2-propyl cyclohexane. Oh golly. All right, here's another extra credit one for you. Noon by Friday +1.